Thank you very much for the introduction, and thank you very much to the organizers for giving us, Tommaso Ghidini, my head of department, and myself the chance to moderate this panel. So I will call the panelists, Paolo Calefati, who is the Chief Executive Officer of Prima Additive. We will have Alessio Lorusso, who is the Chief Executive Officer of Robos, Benny Buller, who is the Chief Executive Officer of Velo 3D, and we will have Paolo Calza, who is the Additive Design and Technology Manager at Avio Aero. And the panel will be completed by Gabriele Rizzi, who is the General Manager of BMIT. Welcome to our panel members. And to introduce the panel, I'll just show a couple of slides giving the background on why additive manufacturing is interesting and important for space and aerospace applications. And of course, we will demonstrate that all through the discussion with our panel members. So if you go to the next slide. So why are we interested in looking at additive for space and aerospace? These are some of the characteristics of materials and manufacturing processes in space. And of course, some of them are also relevant to aeronautics applications. So in space, we are very much concerned with limiting the mass, because every kilogram that we spend to space represents a cost. We have in space typically small production series, typically a few satellites. Now we are moving towards constellations. So for aeronautics, it's also a much larger series. We need very high reliability when we launch something to space. We cannot go and stop on the side of the road and repair, so we have to design the equipment to be robust enough to last for the whole lifetime of the mission. And we have a relatively small set of processes to work with, typically. We span a very large range of geometries, from very small parts to very large parts, typically with the same set of processes. And sometimes we run into challenges when it comes to procurement, also related to the fact that we have small series, so we need a limited number of very specialized materials. At ESA, we started working on additive manufacturing since about 2005, going from experiments looking at what we can do with the material to very simple parts to more complex parts. And in the meantime, we have developed a first standard for laser powder bed fusion, and we have developed 2 harmonization technology roadmaps at European level to define the needed technologies to fill the technology gaps. So, as I said, we started with looking at relatively simple parts. You have some examples here. Injector heads with embedded cooling channels, waveguides, etc. Moving to much more complex parts, from very small, you have here an example of filter, to very large parts. We are working on a prototype for an optical bench, which is about 3 meters wide. And we have reached a point where several of these additive manufacturing parts are flying. You have here some examples of brackets on the JUICE mission to Jupiter, which was launched a couple of weeks ago. And another example on the yoke, the part that the bracket that supports the solar panels on the quantum telecommunication satellite. So just to give you a few examples of where we are at the moment, why it's important. And now I will switch to the panel to demonstrate their day-to-day work on filling those gaps and ensuring those challenges. So going through the order of the panel, I'll give the floor to each one of them to introduce themselves, what they are doing about additive manufacturing for aerospace and space, and what is their key message for the topic. So we can start with, I don't know if Paolo Calefati is here. Yes. From Prima Additive. So Paolo, please introduce yourself and tell us about what you do for the field.
Okay. First of all, thank you for the invitation. Thank you for the opportunity to be here and to talk about what we are doing in this sector. It is important. It is important because for who is working in this sector, in the sector of additive manufacturing, everybody knows that. Okay, thank you. Better. Okay, everybody knows that we are looking for profitable application for this sector. Prima Additive are born from Prima Industrie. Prima Industrie Group is a company that experienced in a laser solution for material processing since 40 years ago. And in Prima Additive, we practically got this experience and tried to translate this experience in additive manufacturing machines. So Prima Additive produces at this moment additive manufacturing machine, both powder bed and direct energy deposition laser solution for metal components. We started working with Aviospazio in the field of powder bed fusion machines, and very soon we developed also some direct energy deposition machine, especially for space application. We talk about combustor chamber and all possible applications that are linked to this component for the satellite launcher. Everybody of us knows that these sectors is very suitable for what we are doing. We passed many years in looking for profitable application for this technology, and we discovered that this sector could provide a lot of application for our technologies. And what we did demonstrate that we have a very good feeling about the development of these sectors. I think that the ESA program and PNR at this moment are providing a very good opportunity for us to develop a good technology, especially for this sector. We focused our attention on machine that use green laser, especially for copper alloys. And then we make some important change, technical change for this kind of technology, introducing not only the infrared laser, but coupling the infrared laser with the green laser in order to improve the material portfolio that could be worked for this sector, especially for Aviospazio. In collaboration with Aviospazio, we developed this double wavelength machine that are capable to work with green or infrared laser depending on the material that we are working. So a bit the focus on the multi-material, especially the material that will be used are used in this sector. The development was very important, and we used this development also for precious metals, because a green laser absorbed about 30 times better by copper alloys, and then this improved not the material property but also the mechanical property of the final components. We had an important collaboration also with the Polytechnic of Milan. Before there was Professor Grasso talking about additive manufacturing, and this development based on green laser was started with them. I think that this solution improved our capability in making machine and technologies, but the most important part is that the technology is not yet mature. So we have to work a lot on the maturity of this technology, and the space sectors is probably the most important sector today for our technology. We have to work together to develop practically what we did, new solution, technical solution, profitable solution in order to improve the industrialization of this technology, to have an industrial approach, and the opportunity that ESA procured, but also the PNRR with the programs is a very unique opportunity for us in order to increase the level of the technology, but also to develop machines that are profitable in terms of operating cost, in terms of quality, in terms of property, on these sectors. Because if you talk about volume, if you talk about complexity, in terms of geometries, material, and so on, space need at this moment all the development that we have to do to match the requirement and the technology at this moment. The other important aspect is the skills, because the technology, I told you, is not yet mature. It's important the ecosystem. The ecosystem means not only technology, not only user, but also skills. And then I think that the Italian competence centers or the academies is a very important role in this game, in order to provide also skilled people that could work and that could increase the level of the final application. So I think that the roadmap that we have at this moment by ISA, by Avio, by the main player of the aerospace is an important roadmap also for us that provide technology. We cannot say that the technology is mature, but we have at this moment important application that require development in order to grow in this sectors.
Thank you very much, Paolo. Looking at the organizers, whether we take the answer from Alessio or we wait for the intervention from the ministry. Thank you very much. So we continue our panel discussion, and the same question goes to Alessio Lorusso from Robos about telling us about what he's doing on additive manufacturing for space and aerospace, and his key message.
Good morning, everyone. Buongiorno. My name is Alessio Russo. I'm the founder and CEO of Robos. Before starting, I really want to thank Giuseppe Acerno and his team for having organized a very nice event. For me, being a local, it's quite interesting, and I'm very proud to see the level of participants, to see the additive manufacturing into the space economy here in Puglia. So thank you Giuseppe, thank you the team. So Robos, I founded Robos back in 2013 after spending many years working on 3D printing as a pure hobby, let's say. So I've built my first 3D printer when I was 17 years old, almost 15 years ago. So a long journey for me. Today the company is both based in Italy and US. So the Italian headquarters, which is in Bari, 1 hour from here, employs almost 100 scientists and engineers. So we developed the entire technological ecosystem that I'm going to show to you in a few seconds in Bari, while the global sales headquarters is based in Houston, Texas. So we are split between the two continents, technology here and business development based in Houston, Texas. Our technology is being considered one of the most advanced technology for 3D printing for super polymers and composite materials. We are very specialized in metal replacement applications, lightweight components, and end-use parts for very mission-critical sectors like aerospace, defense, energy, mobility, and very soon we are going also to enter into medical device sector. More than 400 3D printers installed in 4 continents, serving very strategic customers, blue chip customers like Leonardo, Siemens Energy, GE, and Airbus, US Army, US Navy, and the major aerospace and defense companies and space companies are already using and already implementing our technology for end-use parts production. So we develop the entire ecosystem of our technology. We develop our own 3D printers, patented 3D printers. We develop our own materials and the software. So we created a complete ecosystem to serve our customers, and we help our customers integrating our technology into their production floors, into their production, and into their supply chains. We have machines, very big machines, capable to print up to 1 meter cube. The specialty of our technology is that the technology is very accurate, it's very repeatable, thanks to our patented beltless technology. So our machines are 3D printers, yes, they are, but they are also high temperature ovens, because to process these very high temperature materials like PEEK, PEC, ULTEM, and composite materials, we created the entire ecosystem to heat the part during the entire printing process and controlling all the elements during the printing process, like of course the heating chamber, the extrusion temperature, and all the different elements involved into the process. As I was saying before, we are very specialized in high temperature materials, composite materials, very focused in the top of the pyramid, and in the materials like PEEK, carbon fibers fill PEEK, PPS with carbon fibers, PEC, ULTEM 9085, and the last material we introduced a few months ago, which is a PEEK filled with ceramic fibers for very insulant applications. So space is a very important sector for us. Why this? Because, of course, the space sector has very high entry point, very high standard in terms of acceptance of quality, mechanical performance, repeatability, isotropic performance. So we started to validate the first applications within space sector a few years ago. We are proud with the fact that we already launched some CubeSat in orbit with the University of Colorado Boulder, and through another mission with Thales and Leonardo. So we already validated the technology is ready, scalable, is repeatable at the point to print several CubeSats, which are still in orbit. We are now working with other suppliers, with other space economy players, and we are very proud today to announce our partnership with Nest, which is a local company with an immense expertise with his board members and the partners. And we are combining together the expertise of technology, material science from our side with the space expertise from their side. So this new joint venture will take place in the coming month, and together we are going to promote the use and the implementation and the adoption of our technology within the space sector. Thank you very much. I'll be happy to respond to your questions if you have. I'll be here all the day, and if you want to visit us, it's pretty close. So we'll be more than happy to host you. Thank you.
Very much, Alessio. And the next speaker, the next panelist to answer the question is Benny Buller from Velo 3D. So if you can tell us about what you do in additive manufacturing for space and your key message.
Sure. Could I see that? Hi. Second. Where do I find myself here? Could you? Yeah. It's Alessio. Okay, that's me. So, Velo 3D is an American company, not an Italian company, despite the name. Velo is actually taken from Latin, which means fast, as you probably know better than me. So we developed metal additive manufacturing technology. The company was founded about 9 years ago, 2014, and about 4 years ago we started to sell our products and to ship our products. today we are the second largest metal additive manufacturing company, and at the rate we are growing, we're most likely going to be the largest metal additive manufacturing company by revenue by the fourth quarter. Most of our sales have been so far to the United States. About half of our sales are in the space sector. Between the space, aviation, and defense sector, it's probably about 80% of our sales, most of that in the United States. What we are doing in space, let's see here, second. So what we are doing in space, this is a good example. We make a lot of parts for propulsion, for rocket engines. Practically most of propulsion companies, most of rocket companies in the United States use our machines to produce parts for their engines, the most critical parts, some of them rotating parts. This is an example actually of an Italian engine by our partner in Italy, Avio, that was produced. They already received some machines. So the key about additive manufacturing in space that is really important is that space, as you mentioned today, is a very competitive and very dynamic environment, probably one of the most competitive and one of the most dynamic markets and industries today. And what additive manufacturing allows companies to do is to move to production orders of magnitude faster than what is possible before, and to innovate much, much faster. So as an example, if you noticed a few weeks ago the launch of the Starship, on this Starship we had a few hundreds of parts in the Raptor engines there that were produced on our machines. Those Raptor engines have been in continuous development and continuous evolution while they were in production. So this idea that you can basically start volume production and produce hundreds of engines while you keep iterating on the production, this is something that is quite unheard of in the older paradigm of development. So this is not only allowing companies to make much higher performance at much lower cost, but it also allows much, much faster innovation. So additive manufacturing is really at the core of innovation that we see today in space. And when you look at the space sector in the United States, practically every rocket and launch company in the United States is built around additive manufacturing. Many companies were able to demonstrate an engine in one digit, single digit, or at most $10–15 million budget from inception of the company to first engine firing, which is incredible if you look at how much money and time it used to cost to produce engines in the past. So as I said, additive manufacturing is really about speed and enabling companies to innovate much, much faster and much more agile than it was possible before. Thank you.
Thank you, Ben. Thank you very much, Benny. On our list, we have Paolo Calzanex from Avio Aero. I believe he's online.
Hello, good morning. Can you hear me well?
Yes, we can, Paolo.
Very good. Good morning to everybody. Sorry for not being there. Thank you for the invitation. Today I'm representing Avio Aero on behalf of our CEO, Riccardo Procacci, was not able to join. Avio Aero is a leader company in the design, development, production, and maintenance of aero engines from military to civil applications. It was established in 1998, so just after 5 years on the first right flight. This is just to demonstrate how our inspiration, as let's say, the innovation of technology is part of DNA. So we jump as the beginning to a very emerging technology like the flight that was at that time. So we really believe that technologies can differentiate our product to let's say, to increase our competitive in the aeronautic business. Today, our challenge is linked to create, to design, to produce systems, engines, and process to reduce their environmental impact that can achieve this goal, and at the same time to improve the performance of our engines. Additive manufacturing is a technology that is going really directly on this aspect, because at the same time allow us to design new engines that has higher performance, low emissions, and as well we are producing those engines with a process that has a lower environmental impact. So this is for sure targeting those goals. We are working on the additive manufacturing for more than 15 years, and we are working to develop new engines leveraging on this technology. Today we have basically 2 production sites with almost we are going to have more or less 10 part numbers in series production in our 2 production sites. One is in Kemery, where we have EBM, electron beam melting technology, and the other one is close to you, so it's in Brindisi, where we have the laser technology. On top of that, we have also a lean lab, where I am right now inside the Polytechnic of Turin, where we do the development and the industrialization of our production before transferring to the production site. We are active, of course, in a lot of development on the technology, from materials to working to improve the productivity of the printers, as well as on all the post processing, because of course additive manufacturing is not only printing or printing machines, but there is all the full world around that. In our journey, we have a very important partner that is G Additive, that is a world leader in providing printing machine, concept laser, and ARCA. And so thanks to this integrated effort, we are able to move the technology in the right direction to get a better profitability for our series production. I think as a company, we probably are the only one that have inside the same corporate, let's say, who is going to produce the machine, as well as who is going to use the machine for doing a series production from aeronautic standpoint, so leveraging on the quality system that those parts need to have before being mounting on an engine, let's say, and flying. That's all I wanted
Thank
to
you very
introduce.
much, Paolo. And we conclude this first round with Gabriele Rizzi from BIMIT.
Thank you for inviting me at this audience. I'm representing BIMIT. Almost of you maybe knows this company. We are a service provider in additive manufacturing, in advanced manufacturing. This slide, so there are not more of this. We'll just explain what we are doing. So we are today, let me say, European leader in printing parts. They focused right now on just metal components. In the last 3 years, we changed a lot of our organization. So with the acquisition or selling the minority share to Sandy with the industrial partners, we grow our company with the acquisition of Italian competitor, UK competitor, and other service providers. So today we are a group of roughly under 30 people. So we have 5 production plants in Italy and 3 in UK. With and this is the value of our company right now. We are the integrated value chain on additive manufacturing is in-house. Starting from powders up to the final delivery of the components, all the processes and post-processing technologies are in-house. So 3D printing, the powdering, heat treatments, machining, inspections, we have several post-processing technologies and processes not capacitated. That means the vision of the company was to focus to qualify the processes in aviation sector, space applications, and then deploy all of these knowledge and competencies to all the industrial markets. For us, aerospace domain is covering the 30% of the turnover. The rest is spread between energy, automotive, motorsports, and so on. But the base and the skills that we have developed and analyzed and studied on post-processing and special processes as additive has been focused on aerospace domain, just throws then the processes that apply our knowledge and the competencies on these sectors.
Thank you very much, Gabriele. So because we are running out of time, we have time just for one more question, and you will have about 1 minute to answer that. It's about, we've seen in the previous slide some examples of parts which are flying already, but of course there's plenty of room to democratize the use of additive manufacturing, expand the range of parts that are manufactured and flown. So what do you think is the area we should focus on to increase this market share, if you want, of additive manufacturing? So we start with Paolo.
Okay. Yes. Today, I think the next step is the democratization of the technology. Before I told something about that. In Italy, especially in Italy, for the company who will invest in Italy and investing in Italy, I think that we have a good opportunity. Good opportunity because coming from government, coming from the situation, coming from the ISA program, coming from the Italian competence centers and so on, where we are trying to have this not only technology transfer station, but also some training and education about the technology. The technology is dramatically different from the traditional ones. For us, coming from the industrial traditional technologies, laser cutting, laser welding, we know exactly that we had this change of paradigm, coming from prototype to industrial production. The industrial approach is totally different, but everything starts from the ecosystem, from the education, for training, and I think that here in Italy, especially in Puglia, for me it's a pleasure to be here. First of all, because I born in a town very close to here, Carovigno, and my family live in Monopoli, so for me it's a pleasure to be here. But I think that there is an important ecosystem here in Puglia, and the development opportunity is very, very huge. So we have at this moment to believe in this technology, but to put and to build an ecosystem around what we are making that facilitates the introduction and the integration of these technologies in industrial context. We have not to think that the technology will replace traditional technology. Our vision is that this technology will be integrated together with in industrial traditional context.
Thank you very much, Paolo. Alessio, what is your view on that?
I think that the most scalable applications for us right now is the applications of CubeSats. So we already demonstrated that this is a viable option. The market of CubeSat is booming. So I think that right now this is the most scalable applications. The more we advance with the materials performance, the more we advance with technology performance, with the in-situ monitoring, isotropic properties, etc., the more we will open up new opportunities, especially in secondary, and we hope tomorrow in a future not so far for primary structures as well.
Thank you, Alessio. Benny?
Yeah, so what we see is a lot of adoption of the technology in propulsion, in engines. So started with rocket engines and now moving to aviation, both defense and commercial aviation. And the next thing that we are seeing is moving to much larger parts. So from parts that are a few tens of centimeters to parts that are approaching a meter and hundreds of kilos. And this is, we have customers that are now productizing engines like that. I think that a few years ago, when people were asked what's the largest parts that you will make with additive manufacturing, the answer relied on the image, what's the largest machine that you are going to build for me. When people are now imagining this, they're actually looking on the largest parts they are having and really looking at how to move those parts to additive manufacturing, and the benefits of that are just tremendous, both for supply chain performance and innovation. So I think we are going to see bigger and bigger parts and more critical parts in the structures moving to become additive.
Thank you very much. We move to Paolo from Avioaero Online.
Yeah, I think we have just at the beginning of the revolution, so there is a lot of stuff to do, to develop, to extend the application of this technology. As I said, let's say this technology is stretching all the processes, all the ecosystem. So there is a lot of work to do from the design, where we can print, we can, let's say, create a very disruptive engine architecture that will stretch our designer, our design practice to move in area where, let's say, we've never been, new materials. On the metal, we are using material that were available, not material that has been developed specifically for additive manufacturing. Machines are becoming bigger and faster, so opportunities are increasing by the envelope of the machine. We can include in the printing more subsystem. There are more opportunity also there, and also productivity is increasing. So also the business case is becoming more favorable also for other applications. Other processes that are really stretched by additive manufacturing is support removal or cleaning of the part, removing the powder, heat treatments. We have very complex parts that we need to heat treat. The deformation of the part is also a challenge to have a process under control. Surface finishing for some application is also another important driver. And of course also inspections. We are able to print a very complex part, but then to clear for the flight, for the worthiness, we need to have a capable process to detect a potential defect or to measure the dimension of very complex internal passages. So there are a lot of things to do also outside the printing. And as Paolo said several times, to me, very important is also the ecosystem. So we really need to have closed supply chain for all the processes in order to be more profitable, to reduce the lead time of the releasing the part. We need new competencies. Of course, this is very new technology. We really need a new class of designer designing out of the scheme. There is the digitalization that is also really good for this technology. We have a lot of measurements from the machines that we can use for the online monitoring or to create a digital twin for the inspections, and we are only at the beginning also there. Last but not least, also from standards and regulations, there are some gaps that we need to cover. So this is also part, in my opinion, of the activities that we need to have a more extended and profitable usage of the technology.
Thank you very much, Paolo. And last but not least, Gabriele.
Thank you. My colleagues already covered all the points that we can say from the industrial point of view. So ecosystems, we need to work together between institutions, companies, universities to develop materials, but surely to develop skills, because we need engineering guys, engineering materials, new technologies. Surely the dimension of the machine need to be improved. Just be faster means more lasers. Need to take into account everything around that, and surely finally productivity and profitability of the technologies. Surely we are not, let's say, substituting the traditional technologies, but improving the design. Surely we can improve performance of the components. So this is what additive manufacturing can do.
Thank you very much. We thank all 5 panelists for this first panel, and I give back the floor to Michele for the rest of the program.
Advenit for the moderation